So here's the warm-up for anybody playing along at home. Hi. Pause and do this, and then we'll go over it in a second. But now I would like to talk through some of the homework problems. Now, I think you guys would agree with me that out of all the problems in the homework, 11 through 14 were probably the most difficult ones. If you had any difficulty, it probably came on 11 through 14. The identifying the domain and range. Okay. Now, I will go over the is it a function or not if you'd like to. We can go over 1 to 10. That's totally fine. But I do want to talk a little bit through 11 through 14. I'm just going to kind of hit the highlights here. Now, if I'm asking for domain, what is domain? If I say domain, what do you think?
I think of like all of the numbers on the line.
Okay. Here's what I want you to think. X values. If I say domain, I want you to think X values, input values, left and right. If I say range, what should you think? Y values, up and down, output values. And soon, today, we're going to add to that list independent and dependent variable. So let's take a look here at, number 12. Remember that there's two types of problems here. There's ones where I'm giving you single solitary points, and there's ones where it's a full line. We're going to learn, and I've been kind of using this wording already. In section 3.3, we call them discrete versus continuous. Discrete versus continuous. Discrete is more single solitary points. When you have those single solitary points like that, the domain you list out. Okay, so let's take a look at our values. Okay, we got negative 2, 3. This is 0, 3. This one is 2, 3. This one is 4, 3. So if I have single solitary points like this, I'm just going to list out all of my x values. Negative 2, 0, 2, and 4. Now, this one's kind of odd because my range, well, what's my range? The y values. What is the y value in this one? Just 3. Anything else? No, that's it. So my range is just one number. Okay, now let's take a look. In contrast to that, let's take a look at number 14. Let's take a look at number 14. Now, is this discrete or continuous?
Continuous.
It's continuous. It's continuous because you see the filled in line. Are these single solitary dots? No, this is a filled in line. That means it's continuous. Basically, and again, this is kind of how we'll define it later. Do I have to lift up my pencil when I redraw that?
No.
No, then that means it's continuous. Okay, now, let's take a look at this. Now, when it's continuous, I have to think about my domain to be an inequality. Where does this start in terms of left and right? Where does this start? 0.5. So I go here and I say this is 0.5. And then it goes all the way to, well, there's two tricky pieces to this one. The first tricky piece is the fact that, what is each box? Is each box 1 unit? No. Look, I got 4 boxes for 1 unit. So each box is 0.25. So this goes from 0.5 to, well, if this is 0.25 past 1.5, that's 1.75. The second tricky piece to this is the fact that I did not put or equal to's on my inequalities. Why did I choose not to put an or equal to underneath either one of my inequalities? Why did I do that?
Because the line is always going to keep moving. And always
No. I moved that for you so maybe some of you can see it. The open circles. What did an open circle mean on a number line? Oh, it meant not equal to, right? It meant just a less than or greater than. So, and yeah, that can be the case. You can have open circles on a coordinate plane. That happens from time to time. You probably haven't studied it yet, but that does happen. If you've got open circles, that just means that that's not equal to that point. So it's not equal to 0.5, but it's everything past it. I do the same thing for the range. Let me put those back. And now we'll talk about the range going from here to here. Okay, my lowest point, 0.25. Use my y value, my highest point, 1.5. And that's my answer. Okay, what questions? What other questions would we like to go over? We went over 12 and 14. Is there anything else that you'd like to talk through or go over? Anything else from the beginning of the homework or anything else? Yeah.
The ones like in the box.
Oops.
I'm not sure what numbers it is.
Like 5 and 6?
5 and 6 and then like 4 and 3.
Oh, these ones?
Yeah.
So remember, in a mapping diagram, what makes it not a function? Yeah, the two arrows coming from one input. So this right here makes it not a function. So we would say not a function, no, because 2 has 2 outputs. The one here, do I have any x value having 2 arrows going from it? No, so this is a function. So we would say yes, each x value, each input has 1 output. Same thing here for 5 and 6. You just got to look at the tables. There's 2 reasons why 5 is not a function. There are 2 reasons.
Because the 16 and the 1
Yeah.
have multiple outputs.
Yeah. Because of the 16 and the 1, both those values knock it out. Is 6 a function?
Yeah.
Yeah, there's no repeating x values there. Yeah, clear that up a little bit. Okay, let's jump over to the warm-up because we're going to kind of go over those 2 things again. Yes, last period my screen was being a little laggy, but hopefully it's being all right. Okay, I'm not going to write it out, but again, you should be writing these things out for your is it a function or not. You should be explaining. Number 1, is that a function? Is that a function? No, is that a function?
No.
Why not?
Because number 5 is different.
Good. The input value of 5 has 2 different output values, 0 and 10. Number 2, is that a function? Solomon, is that a function?
Yeah.
Number 2?
Oh, no.
Why not?
Because is that the number 1 that has?
That's 1/2.
Oh. Oh, because it goes to 3 and a half.
Yeah, 1/2 goes to 3 different numbers. Is 3 a function? Is 3 a function, Danielle?
No.
Why not?
Because it doesn't have Well, it's 3.
So if I draw this vertical line, where does it hit twice? So we say yes, it does pass the vertical line test, so it is a function. Does that make sense? A lot of people are trying to tell me, whoa, what if I draw the line this way? Then it doesn't hit twice. Well, that's not the vertical line test. That's a horizontal line test. That's something different. Okay. Number 4, let's identify the domain and range. Now, let me ask you, is this continuous or discrete? It's continuous. It's got a full set of values in between those 2 x values. All right, so my domain and range are going to be inequalities. Okay, tricky part to this one. Does each box represent 1 unit?
No.
No. I have 2 boxes for every 1 unit. So be careful. If you said -1 for your domain, no, that's -0.5. Okay, that is -0.5 here for my domain. And then it goes all the way out to, okay, here's 1, 1.5, 2, 2.5. Same thing for my range. Each box is a 0.5. So I go all the way as low as -0.5 and all the way up to 1.5. Yes.
2 questions.
First question.
So if it's continuous,
Yes.
wouldn't the numbers just keep going?
Only if I had arrows on the end. Because these are solid dots on the end, you assume that it does stop.
Oh, okay.
Second question.
Oh, if it's not a continuous line, would you still write the domain like that?
What do you mean? You'd only write it as single solitary points if you just saw dots.
Oh, okay. Okay.
Yeah. If you saw any part of a straight line, inequalities.
Oh, okay.
All right, let's take a look at our notes for today. So section 3.1, day 2, I'm really sorry, the guided notes, like the copier kept jamming when I was doing the guided notes, and now I know why. Because if you look at your guided notes, they're like slanted on the page. So something must have been a little haywire. I had to like nurse it through. I had to like keep unjamming the copier, and then sometimes it gets temperamental and you just have to like talk nice to it. You and me together.
Imagine just walking in all the
Sometimes you just have to talk nice to technology. Like if it's acting up, you just have to be nice to technology.
No,
Now, are you actually a Guns N' Roses fan, or you just like the show?
Mr. Laverick, if you actually walked in on somebody doing that, what would
I do that in the copy room. I'm like, come on, buddy, we can do this.
What happens
You're gonna be all right
when
today.
somebody walks in on you?
They
doing
just
that?
start laughing. You don't even know any Guns N' Roses songs. You? Yeah. What's your favorite song? Ooh, that's good. How about November Rain? Yeah. The music video for that one?
Guns N' Roses?
All right. So section 3.1, day 2, functions. Now, okay. So what we're going to get into today is more of the application and the real life application of functions. Okay. So how do we do that? Well, the first thing we're going to talk about is independent and dependent variables. Independent and dependent variables. Now, this is something that you've studied before. This is something that you should know. It's something that probably you look at a little bit in science class too. What is changing? What is causing something else to happen? The variable represents the input value of a function. The variable that represents the input value of the function is called the independent variable. So when I say independent variable, you think input. And when you think input, you should think domain, which is also x. See, we've got a bunch of synonyms. Right? Synonyms are words that mean the same thing, like independent variable, like input, like domain, like x. Those are all synonyms of each other. They mean the same thing. Same thing as dependent variable. Dependent variable. Output. Range. Y value. Those are all synonyms of each other. So what we're going to be looking at today is identifying what is my independent and what is my dependent variable based on a scenario. What is my independent and what is my dependent variable? Because in the end, our hope is to try to identify what those things are, because independent variable should be your x value, dependent variable should be your y value. Hopefully, in the end, we should be able to create an equation out of it to model something that's happening. Okay? When an equation represents a function, the dependent variable is defined in terms of the independent variable. We're always going to have y equals, and then something's happening to x. The dependent variable is defined in, so like y equals, it's defined as something happening to x. Maybe it's 2x or negative x plus 10 or whatever it may be based on the scenario. So the first thing that I'd like to do is just identify some independent and dependent variables, because that's our first step. A painter must measure a room before deciding how much paint to buy. So what is my independent variable here? What is my independent variable? And when I ask you that, you should think about, okay, what's going to change to cause something else to change? In the end, we should be able to make the statement, the dependent variable depends upon the independent variable. So what does this situation depend on?
How much paint you use?
How much paint you use? So how big the room is. That's my independent variable. Size of the room. And please reference something numerical. Now, let me ask you, if I change the size of the room, So if I make the variable change, if I make it vary, if I make the size of the room vary, what's that going to cause to happen? What's that going to cause the change of?
The price of how much paint you buy?
Good. Well, it's going to change the amount of paint, not the price, but the amount of paint. Now, again, I'm going to be a little bit picky. Is it okay to just write the word paint? No, because what do you mean? The color? Write something numerical, the amount of paint. See, and I probably would not accept the price of the paint. Because what's it going to change it from $30 a gallon to $35 a gallon? No. The size of the room, if I change the size of the room, it changes how much paint I need to buy. Okay, so we can always make this statement in the end. The dependent variable depends upon the independent variable. The amount of paint depends on the size of the room. Think about it this way. If I had flipped it around, it would not make sense. If I had said the size of the room depends upon the amount of paint. Oh, really? So I'm going to build my room around how much paint I have? No. Okay, let's take a look here. Part B. Yes, sir. Sure. A veterinarian must weigh an animal. I don't know why it says weight. Does it say weight on your guided notes? Or just weigh?
Yeah.
Oh, sorry. A veterinarian must weigh an animal before determining the amount of medication. So let's identify the independent and dependent variable. What is my independent variable? What's my independent variable, Brennan? The weight of the animal. What's my dependent variable? If I change the weight of the animal, what happens?
The amount of medication.
Good. And that's what I'm looking for. Please don't just write medication. Amount of medication. Okay, again, go for something numerical. Go for something numerical. Last one here. A buffet charges $8.95 per person. So this one is a little bit weird. What can change in this scenario? What can change?
The amount of people?
The amount of people. Good. Somebody said, oh, the price. It's not like you're going to take 10 people and it's going to cost like $7 a person. No. The independent variable is the amount of people. Okay. So if I bring more people, what's going to happen? So the total cost is my dependent variable. I'll tell you guys right now, more often than not, when I ask you for dependent variable and it's something to do with price, it's something to do with cost, usually the dependent variable is cost. I'll tell you right now, that's just a kind of a hint. Dependent variable, if it's something to do with cost or money, the dependent variable is usually the cost or the money. I'm not going to say all the time, I'm just saying usually. All right, let's flip it over onto the back. Yes, sir.
Do you have a Band-Aid?
Don't. If you want to write down it. You know what? After we finish notes, I bet Mrs. Naples has, and I'll run over there and give you one. Does anybody have a Band-Aid? You do?
I'll just take a new one. That's not used. Oh, okay.
Why would you? Anyway, so we've got water. Remember, this conversation is all being recorded. Water pressure is 0 psi at sea level. Okay, water pressure is 0 psi, pounds per square inch at sea level, and it increases by about 0.44 psi for every foot an object descends into the water. This is like, you ever swim to the bottom of a pool and your ears pop? That's what we're talking about here. The pressure as you go down underneath water, the further underneath the water you go, the more pressure you feel. Okay, so as I drop something in the water, as I dive down, as something descends into the water, it increases by 0.44 psi per foot. Okay, it asks whether it's a function. Let's first identify the independent and dependent variables, and then decide, okay, is that possibly a function? So what is the independent variable? What is the independent variable here? What's going to change in this situation, Brennan? How far you go underwater. The depth. Okay? If I change the depth, what's that going to cause to change? The pressure. The amount of pressure. Now, let's ask this question. Is this a function? Now, let's think about all that we know from what a function is. So, if I input a certain depth, okay, I'm at 10 feet underwater. Is it possible to have two different amounts of pressure? No, that doesn't make sense, right? I can't, if I have an input, it doesn't make sense to have two different outputs. So yes, this is a function. Each input has one and only one output. If you call it a function, see if you can write the equation. Do we have enough information to write an equation here? What would be my equation? If I'm increasing 0.44 psi per foot underwater. Nathan?
Never mind.
What do we think?
We could do like one input would be like 1 foot and then
Right, so if I put an input of 1, what's my PSI? If I put it 2, what's my PSI? What am I doing with that? I'm multiplying. So therefore I can say y is equal to 0.44x. That's what I'm looking for there. See if you can write an equation to model the situation. Because you know what we're going to have to do next? We're going to have to write the domain and range. Now, okay, so we've got a whale. It's at 1,000 feet. And this is underwater. It does not dive from 1,000 feet up in the air. It dives, that would not be good. It dives from 1,000 feet to 3,500 feet. That's its depth that it likes to stay. 1,000 feet to 3,500 feet. Okay, what's my domain and range? Now, domain is the independent variable, right? So what's my smallest independent variable that I could possibly have? 1,000. What's my biggest? 3,500. Could I possibly have every foot in between there? Does it go between? Yes. So this is continuous. This is not discrete. This is continuous. I could dive to 1,000.5 feet, and then 1,010 feet, and 1,000.1 feet. I could have anything underneath there. So this is the way I have to write it. Now for my range, okay, what is my PSI at 1,000? Oh, we need our equation. We need our equation now to determine this. I need to figure it out at 1,000. I'm going to make myself a little XY table. And I'm going to say, okay, at 1,000, what's my PSI? Well, 0.44 times 1,000 is 440. So that's my smallest amount of PSI. And my biggest amount of PSI, okay, 3,500 times 0.44, which is 1,540. And where am I getting that? Again, that's y is equal to 0.44x. That's my domain and range. Okay, let's take a look at one more of these problems. Sorry, did anybody still need that?
What was the last one?
There we go. Is that better? I'll start reading the next one. We've got a ticket prices, right? Oh no, a theater. Theater can be rented for exactly 2, 3, or 4 hours. The cost is a $100 deposit plus $200 per hour. $100 deposit plus $200 per hour. I'm kind of moving with that. All right, I'm going to jump to the next slide here. Okay. Does this represent a function? Let's identify the independent and dependent variables here, because that might help us decide whether it's a function or not. Okay, what is my independent variable? What does this situation depend on?
The amount of hours you measured it for.
The amount of hours. Good. Okay. If I know my independent variable is the amount of hours, and I change the amount of hours, what's that going to do? What's that going to cause to change? The total cost. Oh, look at this again. Total cost is my dependent variable. Total cost. I should have wrote total cost, but. Okay, now, think about this. Is it a function? If I plug in 2 hours, is it possible to have 2 different amounts? No. If I plug in 3 hours, is it possible to have 2 different amounts that are going to charge? No, that doesn't make sense. I plug in this input, I get exactly 1 output. So we say it is a function. Every input has 1 and only 1 output. So if I say it's a function, let's write the equation. It's a $100 deposit plus $200 per hour. Well, what's my equation then? Go ahead.
So it's 100 plus 100x.
Good. 100 initial fee plus 200x. Now let's use that to find the domain and range. Let's take that y is equal to 100 plus 200x and find the domain and range. Let's make a table. Well, what are the possible domain values? What's my smallest domain that I could choose? 0? They're going to let me rent it for 0? That doesn't make sense. What about 1? Are they going to let me rent it for 1 hour? No. What's my smallest one then? 2. Okay. Are they going to let me rent it for 2.5 hours? No. They're going to let me rent it for 3?
Yeah.
Oh, okay. So this is discrete. This is not continuous. I cannot rent it for every number in between 2 and 4. I can only rent it for 2, 3, or 4 hours. So let's see the cost at 2, 3, and 4 hours. Because that's going to tell me my range. Okay, the cost at 2 hours. That's 100 plus 200 times 2. $500. That's my first element of my range. Same thing for 3. Do that same thing. 100 plus 200 times 3, so 700. And then I do the same thing. 100 plus 200 times 4. And I get 900. That's my domain and range. Do we see how the difference between discrete and continuous there? Again, discrete would be single solitary values, not continuous. Not all points in between, just certain values in between. Yeah.
Are you worried about putting the dollar signs?
You can. I wouldn't take off if you didn't. Yeah. Okay, so for the homework tonight, notice on the homework board it's worksheet 3.1 and page 116, 15 to 18. Guys, for some reason on their worksheet 3.1, they didn't give any independent and dependent variable problems. This worksheet 3.1, I could have given you last night for homework. It's all, is it a function in domain and range? So that's why we added in those 4 problems from the book. Those 4 problems from the book are the independent and dependent variable, write the equation, tell me the domain, tell me the range, okay? And I have it, if you want to get a jump on it, I know we only got like 4 or 5 minutes, but I do have it pulled up on my screen. I'll put it up there as soon as I get back. You could do it just on the back of this worksheet. You can do it on a separate sheet of paper, whatever you want. Stop the video real quick.